Hello guys, and yeah, basically welcome to the next lesson. This will be lesson number 2, chapter 3. In the previous lesson we talked about creating like the P scale and the scale and the rotation. So we are done with that. Let me just change here to a single simple polygonal shape. So we got our copy to points, and now it's time to get some VDB involved, get some remeshing, and get like a basic form. And we can of course influence that with some noises on top here, noises on the bottom. So let's get started. We will need a VDB from Polygon. We will need 2. So the first VDB from Polygon will be like our initial form. So we'll convert that into a simple VDB, but let's get some more resolution here. And of course our boxes. So you can choose, that's again fully up to you. You can get pretty creative with the resolution, because what you already saw for like a second, if you will get like a low resolution and convert that back to polygons, you will get like a more organic shape, and you of course can use that too if you want to. But I will go for higher resolution here, and a VDB combine. And what we can do, we can just subtract the A VDB minus the B VDB. So let's go to STF difference, and we can already see we will get nowadays the subtractive behavior of the VDBs, and we can experiment with that. So what I usually do is get a VDB a shape, so VDB reshape. I think that node is cool, and the VDB smooth SDF. Smooth SDF. And then of course in the end convert VDB. So let's connect that. So the reshape, you can use that in several aspects. First aspect is like dilate, so you can dilate your VDB up to get it more bulky and more heavier. So basically it's like a VDB offset. You can erode it. So I really like the erode function, because you will get pretty organical results. And after the VDB smooth, especially more. So for example, you will get a small hole here, and you will get like a pretty cool behavior because of the VDB smooth. So first try to erode it, and then try to maybe smooth it, or maybe in the other kind of way. So first smooth it and then erode it, and see what will happen. So this is our little base geometry here. We can of course now further influence it. So with another WAP, attribute WAP, we can for example influence our base shape. So I will pipe that up to 5. And of course it's fully up to you. You can use like a sphere or create another kind of base shape with VDBs and feed that into that. That's fully up to you. What I will use, a simple anti-aliased noise, pipe that into position, and the noise to displace along normal. So the position, the normal, you don't need to connect the normal, but I will just do that and pipe that out to position. And you can already see we will get a pretty cool displaced shape fairly quickly. Now of course we got this minus value, so we need to eliminate that. Place a fit range down, and now we can see that. So we got like 0 value and an extrusion or a displaced value. We don't want that. So of course Anti-aliased noise is from range minus 0.5 to 0.5, so source min minus 0.5, source max 0.5. And now you can see we will get a better result here. And it can play with the roughness, with the frequency, with the amplitude. So that's fully up to you. Let's use, for example, a sphere here. I will pipe that up to maybe 50. Pipe it in here. Oh yeah, and we'll get, of course it will get subdivided. I think that will be too much for like the first iteration. Yeah, 9 million polys, I think that's a little bit too much. And we'll use, or I will use the loop. Let's get that. And of course now you can try out what you want. For example, something like that. Or what you can do, you can use, for example, another kind of noise. That's of course fully up to you. Let's see what we will get with that here. We do from polygons, yeah. Of course, now what you need to do is to pipe our multiplier a little bit up to get like this shape. Randomize it. And what I will do, I will make it a little bit like thinner. So we will get what we will get. Yeah, that looks not bad. So VDB reshape. Of course now for the erosion part you can go pretty high, like 15, or make it even higher. That's fully up to you. So we will end up with something like that. That's cool for now. And what I usually do, I try like out bending it. So get the bend involved here. And I will set a capture region from maybe here to here. And now you can try out like different bending iterations to like bend it a little bit, or what I usually do like twist it, or what's also good is like the length scale, and of course the taper. So you can taper it, for example, make it thinner on the top, make it thinner on the bottom, squish it a little bit. And now we can place down a null and, for example, call it out base, and then we can further proceed. So what I want to do is like place down again a WOP, attribute WOP, or use a point WOP, and create base noise. So we already created a little bit of noise, but just for our base form. Now we will create like a noise that's a little bit more advanced, and we'll get our like a little bit more mineral or rocky feeling. And we can do that pretty easy. So I will go again for anti-aliased noise. The position, I will fit that. So we will fit again the range, and for example pipe it out to the color. So minus 0.5 to 0.5. And What I want to do is like get a unified static noise, get here the position into the position, and for just visualization purpose I will use simply the color for output. And what I want, the volley cellular noise, for example, just pipe the frequency a little bit up, something like that, so we will get like a unified pattern over this. Of course you can experiment a little bit with standard fractal type. That's fully up to you, but of course try it. So fractal type with standard or hybrid terrain is really nice to do. And what I want to do, I will just multiply that. So let's have a look on that noise again, and maybe place on a ramp here. Where's the ramp parameter? What I want to do, just want to influence the noise here a little bit to make it maybe a little bit more sharper, so to get something like that. And I will multiply both, so they will like cancel out each other or influence each other a little bit. Again, this plays along normal, and we will pipe the multiplied output into the amount, and then of course to the position. And now we can see we will get some pretty heavy results here. Let me just frequency, we can do that later. Of course, now what you can do, you can adjust your noise here. So we will get this pretty rocky noise, and also the anti-alias noise. For the anti-alias noise, maybe we will consider to go a little bit back or higher. So of course that's again fully up to you. So now you can just play with the values, and of course currently it will look not so good, but we'll just remesh the whole thing. Like you can go for like a little bit bigger pattern, and you can of course change your anti-alias noise a little bit. So if you pipe that again out to the color and just quickly remove that, you can see now it's maybe too wide. So I will stick for frequency of 1 now, and we will of course remesh that. So after the noise creation, of course you can fit it to not get like these massive intersections, but I usually like them because you will get a pretty nice interesting geometry results after remeshing. So what I will do again, VDB from polygons, pipe that into here and a convert. And I think that's just a matter of try things out, try nodes out. So for example, what you can do now, if you just remesh it like that, I think it will look pretty cool. But what you can use, just use for example the erode here again. So VDB reshape, pipe that into our VDB and maybe erode it. So of course the form is now much more simpler or simplified, but you can use that, for example, like a value of 2. And I think you will get pretty cool results here. So this is like now our base geometry. So our second iteration, let's erode it a little bit more. And I think it looks pretty cool. What I will do now, let's go for a higher resolution, so 0.005 maybe. Yes. And what you can do after that, of course, introduce another layer of noise. So we will do that for now. Again, place down a VOP. And what I really like is the unified noise. Of course, you can try out other noises, but unified noise is pretty cool. Into the position and then displace along normal. That into amount, the other one in position. And that's just for visualization. For example, what I like is the Manhattan F1 or the simple sparse convolution with a fractal type, so that's pretty cool. You can try that out. And just pipe that into position. Of course, that's now way too high, so scale it down to like 0.05 or 0.01. So we will get a little bit of extra noise detail here. Final amplitude, you can try that out. Hybrid terrain. Like 5. Yes, that looks better. Fast is also pretty cool because you will get these little details here. And again, after that, just remesh it. So it's like a remeshing process. Of course, you can leave it at the first iteration, but yeah, I think you will get a pretty good result after that. So erosion. Or you can try a dilate, so I think that's fully up to you. You can also try open and close, but I will use the erode function for now. Let's go like crazy for 50. Yeah, some errors here. Let's try out a smooth, just for. Of course you will smooth it, but for example, if I go for a pretty high value, it will smooth out, I think, pretty much of the details. Yeah. Yeah, it will smooth out like the details here. But I think when you go like for like a 2, it will not be that harsh. Okay, it will be harsh. So again, that's fully up to you. So I will try to erode it one more time. Yeah, of course, 50 way too high. Maybe 5. Try out values that will fit and you will like. But I really like that for now. Looks pretty good to me. And we can further proceed with that. So I will place down a null. Out iter base for iteration. And I will see you in the next lesson. So in the next lesson then we will deal around with measuring, and we'll start the scatter setup for our minerals.